Today we're going to be looking at the Chapter 3 closure for Integrated Math 1. I'm on problem 142, so they want you to write each of the products as a sum. So for part A, I distributed. I took the 6x and multiplied it by the 2x to get 12x squared. Then I took the 6x, multiplied it by y to get 6xy. Then I took the 6x and multiplied it by -5 to get -30x. Part B, I use the algebra model. So we're going to I wrote the binomial 2x squared minus 11 down the side and the x squared plus 4 across the top. And then for each box, I multiplied to the left and above to get the product inside. So 2x squared times x squared is 2x to the 4th. 2x squared times 4 is 8x squared. -11 times x squared is -11x squared. And -11 times 4 is -44. The only like terms I found were these two, which combined to get the -3x squared. The other two terms stay separate. Part C, I could have done the algebra model, but this one was pretty easy. I just multiplied the coefficients to get the 14, added the exponents of the x and x to get x squared, and then just the y. For part D, I used the area model again, multiplied the 3x to get 3x, multiplied the 3 times -2 to get -6, multiplied the y times x to get xy, and multiplied y times -2 to get -2y. There are no like terms, so all four terms stay separate. For problem 143, it says plot the triangle MJN on graph paper with the vertices 16, -8 is at M, 16, 2 is at J, and 4, 0 is N. So I plotted the 3 points. I created a rectangle out of it and counted the sides. This side was 10, this side was 12. So to get the area, I multiplied the 12 times 10. Because it's a triangle, I divided by 2. So 120 divided by 2 means that the triangle is 60 units squared. The directions for question 44 say perform the indicated transformation. Label each of the image using your prime notation. So for the part A, they want you to rotate the figure EFGHI 90 degrees clockwise about the point Z. So I used my tracing paper and created axes through Z. And then when I rotated it, I got the following transformation. So I just laid it on top and turned it and saw that at 90 degrees, the figure ends up there. Part B is a reflection over the line T. So every point is equidistant. So K is the same distance here to K prime. L is the same distance here to L prime, M is the same distance to M prime, N is the same distance to N prime, and J is the same distance to J prime. Turn it over to the back. At the top, question 44 says to translate the figure down 4 units, which is a change in the Y value, and to go to the right 3 units, which is a change in the X value. So if you found the location of each of them, you could simply add 3 to your X and subtract 5 from your Y and plot the new points. Question 46, they want you to graph the segment that connects the point A, which is at -4, 8, so I went 4 to the left, up 8, put a point and called it A. B is at 6, 3, so I went 6 to the right, up 3, drew a point and labeled it B. So I counted the slope. From this point to the next corner was down 1 over 2, down 1 over 2. So the slope is -1/2. Then they want you to write an equation. So I discovered that it intersects the y-axis at +6. So that plugs in for B, and I know the slope is -1/2. Part C says write an equation for a line that is parallel to line AB. If it's parallel, it's going to have the same slope. So I wrote y equals -1/2 x. And then any number can plug in here. I picked -3, but you could put +12, whatever. Any number can go there. Same for D. Write an equation for a line. This time it's perpendicular to line AB. So I took the opposite reciprocal. So if this one's negative, this one has to be positive. Then I take the fraction and I flip it, which would be 2 over 1, so I just simplified it to 2. And then I picked a random number here. I picked 9, but it could be any number. Question 147. Write the equation of each line from the given representation. So for part A, they graphed a line for us. I counted the slope as negative 2 over 1, and I found the y-intercept at positive 3. Part B says a line with a slope of negative 2/3 that passes through the point negative 3, 4. All right, so you're going to take these three numbers and plug them into the equation y equals mx plus b. So 4 goes in for y, negative 2/3 goes in for m, and negative 3 goes in for x. I wrote it as negative 3 over 1, so the 3's would cancel. A negative times a negative is a positive, and so I got plus 2. So I subtracted 2 from both sides and found that b equals 2. So I plugged it in over here, and the slope is negative 2/3. For part C, I was trying to figure out the slope, so I noticed that the change in y is 2, the change in x is 1, so the slope is 2 over 1. And I just continued the pattern and found that the y-intercept would be at negative 3. So the equation of the line is y equals 2x minus 3. Turn over to the next page, top of page 35. For problem A, we wanted to add these two mixed numbers, so I took 8 times 9, 72. Oh, that's where the 70. All right, so for problem A, 148, we're going to change this mixed number into an improper fraction. So you multiply 9 times 8, which is 72. 72 plus 2 is 74. So it's negative 74 ninths. For the second one, you multiply 5 times 7, which is 35, plus 3 is 38, so 38 fifths. Then you need a common denominator, which I found was 45. So 9 goes into 45 5 times. 5 times negative 74 is negative 360. 5 goes into 45 9 times. 9 times 38 is 342. Then you just combine the numerators to get negative 28 over the new denominator of 45. For part B, I simply combined these because I already had common denominators. So negative 4 minus 5 more is negative 9. Negative 3 minus 3 more is negative 6/8. So then I just reduced it to negative 9 3/4. Part C, I changed these to improper fractions first. So 4 times 10 is 40, plus 3 is 43/4. 8 times 9 is 72. 72 plus 4 is 76, so negative 76 over 9. I saw that these were both divisible by 4 and reduced, then multiplied straight across. 43 times negative 19 is negative 817. 1 times 9 is 9. So I just changed it back to a mixed number. Part D. This one involved division, so I need to use the invert and multiply rule, but first I changed them to improper fractions. So 4 times 8 is 32. 32 plus 3 is 35, so negative 35/4 divided by negative 5/7. Then I took that second fraction, flipped it, and changed the sign to multiplication. Saw that I could reduce this way, and then multiplied straight across. Negative times a negative is a positive. So I got 49/4, and then changed it to a mixed number. 4 goes into 49 12 times with 1 left over. Question 149 says Charlotte was transforming the hexagon ABCDEF. What single transformation did she perform in diagram 1? So she just reflected it. They're all the same distance from about the line that's about right there. Part B says what single transformation did she perform? And that looks like a rotation. It's just turned this direction, or technically you could turn it that direction too. Part C, what transformation did she not do? That would be a translation. Right directions for this type of transformation, I added 3 to the x and subtracted 4, so I moved 3 to the right and down 4 on all the points. So it moved the whole figure over 3 and down 4.